Okie dokie. Alright, so welcome to this lesson. How do we investigate ways to find interior and exterior angles of polygons? Alright, so you got your learning targets right here. Let's start with this mini lesson. Alright, this is like the easiest thing ever. So let's see. Okay, polygon. Alright, it's a closed figure. And when they say regular polygon, they are referring to a geometric shape that has all sides congruent. You see, that's your word. You don't say equal sides, or you could say sides equal in length. But for the purposes being, we're going to say congruent. All right, so a triangle. You're going to answer these questions, and I am going to really just facilitate here. All right, so a triangle. How many sides? Yes. And you better be quick here when you answer because I'm not giving too much time. Okay, quad means cuatro if you speak Spanish. If not, quad, like in the ring, in a quadrilateral, has 4 sides. And I'm giving you the shape, so 4 sides. The pentagon, like the one in Washington, has 5 sides. You could count them. Hexagon, 6 sides. Okay? Heptagon, 7. Octagon, 8. And the rest, so on and so forth. Okay? Alright, cool then. What else do I need to know? The number of triangles. Well, how many triangles do you see here? Exactly, 1. Alright. What else? In a quadrilateral. Okay, we are going to be forming triangles, okay, using diagonals. Alright? Now, a diagonal, this is not a diagonal. 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 Okay, let me get a color pen. So, this is a diagonal right here. Okay, that's a diagonal. Now, the way we do it is the following. When they ask us for how many triangles, yes, I know I can draw another diagonal here, and I'm gonna say that I have 4 different triangles. But no, that's not how the way we want to do it. We want non-overlapping diagonals. So this is either you draw this diagonal or you draw this diagonal. But that's it. So how many triangles do you see? 2. Okay, so 2 triangles. Here, look at the diagonals. This is not a diagonal. 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 And this is not a diagonal. This is one diagonal. Guess what? This is another diagonal right here. I cannot draw any more diagonals. Okay? A diagonal is not a side of a polygon. So how many triangles do I have? 1, 2, and 3. Okay. Here, diagonals. Okay. If you want to, you could just use a ruler. So I have 1 right here. I have another one over here. And I have another one over here. All right. That's it. That's as many diagonals as I can draw. You could have started from here, and you're still going to go like 1, 2, and 3. Anyway, so how many triangles do I have? 1, 2, 3, 4 triangles. Okay, so with this is enough for us to make our conjecture. Let's go on to the next one. It says sum of the interior angles. Well, in a triangle, we know that the sum of the interior angles is 180 degrees. Now, in a quadrilateral, how many degrees? Well, we know it's 360. But it gets complicated when we talk about the pentagon. Because now in a pentagon, how many degrees do we have? Well, I don't know. Let's see. In a triangle, I have 180 degrees. Look at this shape right here. How many triangles do you see in the quadrilateral? 2, right? So if each triangle has 180 degrees, then between 2 triangles, I have 360. Oh, Becca, you mad nice? Yes, I know, I am. So guess what? Here I have 1, 2, 3 triangles. Oh, okay, 3 triangles. So that means 3 times 180. Wait, 3 times 180. 3 times 180. Okay. 540. In a heptagon, I have 1, 2, 3, 4 triangles. I have 4 triangles. So all I gotta do is 4 times what? Right, 4 times 180. And guess what? I have no idea. So I'm going to have to multiply. That's 720. Okay. Now, watch this. We're going in order here, so I'm not skipping. So this has 3 sides, 4 sides, 5 sides. Look, hexagon, 6 sides, heptagon, 7 sides, octagon, 8 sides. So, based on our conjecture, how many triangles, without drawing the diagonals, how many triangles do you think I am going to have in a heptagon? Right, I'm going to have 5. In an octagon, 6. And then 7 and 8. Okay. So, we already know that the number of triangles is this column right here. And we already know, how have I been obtaining the sum of the interior angles in each of these polygons? I multiply the number of triangles times 180. So, in a heptagon, I have how many degrees? Tell me. Okay. And now in an octagon, how many degrees do I have? If you tell me before I write it down, I'll give you 1 point to my students. Okie dokie, 1080 HD resolution. And then of course I'm helping you with the others right here. Okay. Funny, now it becomes funny. Because, no, you know what, before I move on, I need to come up with a formula to find out what is the sum of the interior angles of each polygon. Well, in the triangle it was 180. 1 times 180. So I'm saying that the number of triangles in each figure times 180. Yeah, but how do I determine the number of triangles in each figure? What if I had a figure that had 20 sides? How many triangles would I have in a figure of 20 sides? Well, take 30 seconds and analyze this diagram right here and tell me how many triangles would I have in a figure that has 20 sides? Correct, I will have 18 triangles. But then, how did you figure that out? Well, look at the number of triangles and look at the number of sides. What do you see? The number of triangles is what in comparison to the number of sides? 10 seconds. Correct. The number of triangles is 2 less than the number of sides. So then we could generalize a formula, okay, for the sum of the interior angles of any polygon. Watch this. N will represent the number of sides. This number of sides. Number of sides minus 2. So number of sides minus 2. And what do we do with each triangle? Once we have it, we multiply it by 180. So then I can come up with a general formula saying that the number of sides take away 2, okay, gives me the number of triangles. And then I just have to multiply that by 180 and I get the sum of the interior sides. In other words, the total number of degrees in each figure. Ah, nice. Okay. So now let's talk about the measure of each interior angle. The measure of each interior angle. We're talking about regular polygons, so we're talking about that each side is congruent. So then each angle is also congruent. Perfect. In a triangle, if it's equilateral, that we know that there is 60 degrees in each. So the measure of each interior angle is going to be 60. Okay? Now, in a quadrilateral, what is the sum of the measure of each interior angle? Well, how do I do this? Becker, why you overcomplicate yourself? Look at this relationship right here. The sum of the interior angles, how many degrees? All you have to do is divide by the amount of angles that the polygon has. What I'm trying to say is this: if a polygon has X amount of sides, then it has the same amount of angles. So this one has 3 sides, it has 3 angles. This one has 4 sides, it has 4 angles. 5 sides, 5 angles. 6 sides, you see that? Okay then, so if you have 180 degrees, just divide by 3 and you get 60. So if you have 360, divide by 4 and you get 90. And then 540 divided by 5. Tell me before I do it, and I give you 1 point. And now let's do the hexagon. 720 divided by 6 is 120. Okay. Then let's do the next one. 900 divided by 7. That's let's see now. Okay, that's what he says. That's what he says. 128.6. 128 point. Actually, it says 5.7. So I'm gonna put 5.7. But if we round, it's gonna be 0.6. All right. Now let's do this one. The octagon. Octagon. Now, where is the H? So we got 1080 divided by how much? Okay, this is gonna be divided by 6 or divided by 8. 1 point. Right, divided by 8, I get 135. And of course, the rest is already laid out for you. So now, how do I figure out the measure of each interior angle? Hello, take the sum of the interior angles and divide it by the amount of sides. So that's exactly what we're gonna do. Look, we take the sum of the interior angles, which is this formula right here, and now we're gonna divide it by the amount of sides. Nice, Becca, nice. This is something that you're gonna have to watch over and over so you get the hang of it. But because you don't have to rely on the formulas, you could just rely on your common sense and you could figure out the answers. All right, so the sum of the exterior angles of each of these polygons. Well, how do I get exterior angles? All I gotta do is extend each of the sides like this. Okay, Sharingan. Okay. So if this is 60, since this is a straight angle, is 180. So 60, then this is 120, right? Then this is 120, and this is 120. So the sum is 360. Okay. Now what about this one? Well, each of these is a right angle, measures 90 degrees. So if I extend each of the sides, right, I'm still gonna end up with 90 degrees. Okay. So 90, 90, 90, 90, that's 360. Can we already make a conjecture right now? What would be your conjecture right now? What would be your conclusion? What can you deduce? What is this, and this? I would have just looked at the bottom right here and see that since they are the same, I'm like, come on, it must be a pattern. Of course, a pattern, okay? And I'm gonna give you one last example of this 360. Look, if you extend, okay, each of this, all right, they're all gonna be the same measure. So the sum is 540. The interior angle is 108, so this is 108. So if this is 108, this must be 72. And this is 72, 72, 72, 72, 72. That's 5 angles of 72. And if we do 72 times 5, guess what we get? Boom, 360. You meant nice, of course. All right, then, so that's that. Now, measure of each exterior angle, same thing. You got 360 degrees as the sum. So all you gotta do is divide, well, you already know this. 360 divided by the amount of angles or sides. So 360 divided by 3 is what? 120. Okay. Now tell me what you get for the quadrilateral. Of course, you're gonna get 90. But we already figured that out. You see, we figured that out that it was 90 without using the formula, because we already know how to create exterior angles. Just like this one. The interior is 108. Okay? And watch this. The interior here. Let me zoom in if I can. Yes, I can. Okay. The interior is 108. This part right here is 108. But since when I extend the side, I create a straight angle, which is 180. So if this is 108, then this gotta be 72. So therefore, I don't have to look at the shape anymore. I can just say, okay, if this is 108, then this is gonna be 72. If this is 120, this is going to be 60. All right. Now, guess what? The next one is 128.57. So, I could still figure out what the other one is. What is the supplement of this? The supplement means like, you know, add up to 180. So, it's 51.43. See that? Now here, 135. Okay? Take 20 seconds and tell me what it would be the measure of the exterior angle on an octagon, knowing that the interior measure of one angle is 135. Right, it is 45. And so on and so forth. Here we have the formulas, okay? If you want, whenever you are solving problems relating to exterior and interior angles, just refer back to this formula. If you're not my student, then just go back to this video and the formulas are right here. But I'm pretty sure that you can do it. You can do without the formulas. All right. So now let's see what else do I have in stock for you. All right. So here we have our independent practice. So we're gonna start with the problems. So let's see what's up. Okay, find the sum of the degree measures of the interior angles of a regular polygon that has 8 sides. Okay, what do I need? The sum of the interior angles. So I know it's 8 sides, so it's an octagon. What is the relationship between the sides and the triangles? Well, the triangles are always 2 less. So this gives me the amount of triangles. So I have 6 triangles. And what do I do with those triangles? I times them because each triangle has 180 degrees. So I times it by 180. So 8 sides. I'm not even going to do with the calculator. I'm just going to go back to the last page. Look at the one that has 8 sides. Okay. And the sum is 1,080 degrees. Right here. Okay, next problem. Okay, it says find the number of sides in a polygon whose sum of the interior angles is 1440. Okay, so there are 2 ways of doing this. I could do it the slow way, which basically that would be like finding, okay, I got the triangle, I know that the octagon, like the octagon that has 8 sides, like the one here, has 1080, like this. The octagon equals 1080, okay. I know that the nonagon will be what? 1 more triangle, so therefore, I just have to add 180 degrees more. So, that will be what? That will be 1260. That the decagon, okay, all I have to do is add 180 more, okay, and that will be 1440. Oh, nice. So, guess what? You write down your answer. It says, okay, the number of sides of the polygon is 10. It's a decagon. But, why would I want to do this if I already generalized the formula? Okay, the number of sides. How do I find the number of sides? Well, look. This is the number of sides. And we know that if we take away 2, we got the number of triangles. And if we times by 180, we get the sum of the degree measure, right? which in this case is 1440. Okay, so I would just solve this equation. Two things. You could do two things. You could either distribute right here, which why would I want to do this? The way I think of this is the following. This quantity is being multiplied by 180. So I'm going to divide by 180 on both sides. You see my reasoning? Now, guess what? This 180 cancels out. And now all I need to know is what is 1440 divided by 180. Well, 1440 divided by 180 is 8. Because that's what it says. So, n minus 2, okay, n minus 2 equals 8. When you divide the total sum by 180, you're going to end up with the number of triangles. So 8 is the number of triangles. But remember that the number of triangles is always 2 less than the number of sides. So what number minus 2 is 8? 10. Or if you want to keep on solving, you add 2 to both sides. And you get your 10 right there. So whichever way you want to do it. I showed you both ways because right now this is simple. If it comes to a point where you cannot figure out, like if they ask you, okay, what is the sum of the interior angles of a shape that has 42 sides, I suggest you use this. Okay, it's not complicated. All you have to, you know what, I could rewrite this formula. If you already know that the number of triangles is 2 less than the number of sides, I could rename this formula as number of triangles times 180. See that? I don't have a problem with that. All right, next problem. Find the sum of the measure of the exterior angles of a polygon that has 12 sides. Okay, the sum of the measures of the exterior angle. It's always like that. What is the measure of one exterior angle? Well, if the polygon has 12 sides, then what am I going to do with this 360? Exactly. So now tell me what will be the measure, and I give you 1 point before I do it, which I already did. As I'm talking, I'm doing. Ha ha ha. So it's 30 degrees. All right, let's move on. Find the number of sides of a regular polygon, each of whose exterior angle contains 72 degrees. It's a pentagon. How? I know it. I've seen it before on the last page. We saw it. But anyway, let's do it algebraically. Okay? So the number of sides. So I know triangle times 180 is going to give me the sum of the sides. Okay? Wait, hold on a second. This is not the same way. Find the number of sides. Okay, we know it's a pentagon, but let's see how to figure this out. Find the number of sides of a regular polygon. Oh, the number of sides? Sure. Let me do this. Let's see if I can figure it out just by doing the following. So oh my God. Each exterior angle contains 72 degrees. So we're talking about the exterior angles. Come on. So I'm sorry, I made a mistake. It was just this. We know that the sum of the exterior angles is 360. So I'm going to divide by 72. Okay? If I divide by the amount of sides, I get the amount of degrees. So if I divide by the amount of degrees, I'm going to get the amount of sides. See that? I wonder, is there a formula for that? Let me see. Measure of the exterior. No? Yes, the formula is 360 divided by n for the exterior angles. All right, cool then. Find the sum of the measure of the exterior angles of a polygon that has 9 sides. The sum, we already know that, right? What is the measure of one exterior angle? Well, it has 9 sides, so you know what to do, right? To find each exterior side, So basically it has 9 sides, so it's a nonagon, so it has 40. Plus, we could always go back to this little page right here, and you'll see that it's there. All right. Stop saying all right. Say something. Booyah! No. Okay. Here, number 6. Find sum of the exterior angles. Okay. So A, we already know is 360. Right? Sum of the interior angles. Okay, so interior angles, it has 5 sides, and if it has 5 sides, it only has 3 triangles. So for B, it has 3 triangles, so 3 triangles, I'm gonna times over 180, and I'm gonna get 540, which we already knew from the chart before, from the previous chart. All right, what else? Find the measure of each interior angle. Well, if you got 540 degrees, all I gotta do is, common sense tells me to do this, and I am going to get 108. Okay, last but not least, for D, it says find the measure of each interior angle. Oh, we already did. Wow. Fine. Okay, I thought they were gonna ask me for like the measure of each exterior, and I already know that if this is 108, this was gonna be 72, but okay, fine. Okay, next problem. Come on, clear. Okay. The interior angles of a regular polygon are each 120. The interior, calculate the number of sides. Well, I cannot say from the interior angle, but guess what? I know what the measure of one exterior angle is. Tell me what the measure of one of the exterior angles is if this is 120. Aha. So yes, it's 60. So interior angle is 60. Now I know. Beker, you're making mistakes again. Let me see. Not the interior, the exterior. Okay. So the exterior angle is 360. I'm sorry, 60. So now I'm going to calculate the number of sides. How? Easy. I know that the sum of the exterior angles is 360. And I know that one exterior angle is 60. Therefore, this thing has 6 sides. Nice. Okay. What? We got more? How much more do we have? Oh gosh. I want this to be over. It's okay. Alright. Let's move on to the next problem. So, we have a pentagon here. Notice that this is not a regular pentagon, but it's still a pentagon, and it's still, the sum comes out to 540. It's just that each angle is not congruent. Alright, so what do they want? What is the degree measure of angle X? Alright, so let's see now. Angle X. This is angle X. So we're talking about an exterior angle. Alright, so let's figure this out. 84. Okay. 84. Now, this is the way I would approach this. The sum of the exterior angles is supposed to be 360, but I am missing this angle right here. And how can I figure out this angle? Well, look at this. This is a straight line right here. You see, it's all about straight lines. You know what? Let me see if I can zoom in. Okay, better? Yes, better. Okay, so this is 140. This gotta be 40. Okay, right here. This 40 is gotta be 40. This 140 is gotta be 40 because the straight angle is 180 degrees. All right. What else am I missing? No, that's it. That's all I was missing. So now I just gotta add 1, 2, 3, 4 angles, 4 exterior angles, and subtract them from 180. All right. Do it before I do, and I'll give you 1 point. So the measure is 108 degrees, making your answer choice number 3. And your answer is 108 degrees. All right, let's move on to the next problem. So the number of degrees in the sum of the interior angles of a pentagon is, oh my God. In the sum of a pentagon, guys. Okay, now to show work. Okay, let's say I need to show work. So we use the formula for the sum of the interior, which is n minus 2, which gives you the number of triangles, and then times 180. Okay, we know that it's a pentagon, so it has 5 sides. Okay, minus 2. This is boring now. Okay, it is, right? So we got 3 times 180, and that gives you 540 degrees. You understand this? This is showing work, whether it's multiple choice or not. All right then, next problem. In which polygon does the sum of the measures of the interior angles equals the sum of the measure of the exterior? Okay. Oh my God, I made a mistake again. I hate this. In which polygon does the sum of the measure of the interior angles equal the sum of the measure? Oh, no. I didn't make a mistake. I'm nice. Because the sum of the exterior angles is 360 in any polygon. So which is the polygon that has 360 degrees in the interior? Well, it's the quadrilateral, because look, 90, 90, and 90. And this is 90, 90, 90, and 90. So 360, 360. Nice. Move on. Okay. In the diagram below of regular pentagon, ABCDE, EB is wrong. Alright, so what is the measure of angle AEB? AB. Okay. Watch this. They told you already, this is a regular pentagon. Regular means that all sides are congruent. Therefore, all the angles are congruent. And what is the measure of one interior angle of a pentagon? Okay, you should know this already. If not, then you're going to have to figure it out. Okay, how? Knowing that this thing has 540 degrees altogether. Okay, and then when you divide that by 5, you end up with 108 degrees. Okay, in each angle. So this is 108. This is 108. This is 108. Oh gosh, I don't know how to do this. Help me. Okay, so regular pentagon, all sides are congruent. This side is congruent to this side, to this side, to this side, to this. Oh, I got it. I think I got it. Wow, but this brings back memories. So this is a triangle right here. And I'm supposed to find out what the measure of AEB is. In this triangle, 2 sides are congruent. And I think that if 2 sides are congruent, that makes this triangle an isosceles triangle. And there is such thing as the isosceles triangle theorem. It says that angles opposite to congruent sides are congruent. So that means that these 2 angles are congruent. Therefore, the measure of this angle is equal to the measure of this other angle. Yeah, the only thing is that how do I figure that out? Well, this is the way I would do it. In a triangle, I have a total of 180 degrees, which I already have 108. So 180 minus 108 is 72. Now, there are 72 degrees flying among these 2 angles. Tell me, what is the measure of this angle then? Correct, is 36. Therefore, now I can make my choice. And the measure of angle AEB is 36 degrees. Got it? All right. Hope you understood this. If not, you're gonna have to watch it over again. Okay. Oh, this one. All right. Let's see now. This is your quiz. And the funny thing is that on the last video that I made, on lesson, I think it was the mid segment, the last part did not, those problems were not about mid segments, but now I understand why, because that was the quiz. But anyway, all right, so it says in the diagram below of ABC, AB is 10, BC is 14, and AC is 16. Find the perimeter of the triangle formed by connecting the midpoints of the triangles of A, B, C. Okay, from now on, this is the last time I'm gonna do this one of these quizzes, but from now on you can just refer back to the last video that I made and just answer your quiz. So the midpoints right here, boom, boom, and boom. I'm gonna connect the triangle. Okay, you could use a ruler if you want to. I'm just doing this fast. So we're talking about connecting the midpoints. So we're talking about mid segments. So if this is 16, this is 8. If this is 14, this is 7. If this is 10, this is 5. So now find the perimeter. All right? You know how to do it. Now let us go over here. Remember, when you answer, you said the perimeter of the triangle form is blah, blah, blah. All right, then. So let's see what's up here. On the set of axes below, graph triangle DEF with vertices, and we have these vertices right here, okay? If G is the midpoint of EF and H is the midpoint of DF, say the coordinates of G and H and label each point on your graph. Explain why GH is parallel to DE. We did this before. I'm just gonna do like a quick version of the problem. So let's see now. D is -4, -4. So -4, 1, 2, 3, 4. So this is my first point right here. Then I'm gonna call it D. Then E is -2, 2. So E is -2, 1, 2. This is E. Then we have F. You should be able to plot points faster than this. So F is 8, -2. So 8, -2. That's F right here. Okay. If G is the midpoint of EF, okay. So I guess I have to connect this, of course. All right, so right there. To find midpoint, you use the midpoint formula as I showed you before, okay? So at plain sight, I can tell you that this is the midpoint and that this is the other midpoint. So I'm gonna connect them. Okay, you take a look at the slope, okay? Now the coordinates here are 3, 0. And the coordinates here are, what the hell? 2, -3, okay. And how you got it? Well, you use the midpoint formula. You add the x's and divide by 2. So, for example, EF, okay? EF, E, and F. Okay, coordinates of E are -2, 2. And the coordinates of F are 8, -2. So now to find the midpoint, I do the average of the x and the average of the y's. So the average of the x. So let's find the midpoint of the x's. So I get, this is gonna be the ones and this is gonna be the twos. Okay, so I know in which order they are. So that would be -2 plus 8 divided by 2, and that is 6 divided by 2 is 3. Now the midpoint of y, that will be 2 plus -2, so that will be 2 plus -2, sorry, divided by 2, and that is 0 right there. Okay, and that's why find the midpoint, you get 3, 0. Now guess what? You gotta do the same thing for DF. Okay, so you write down DF. So the corners of D, the corners of F, and you find a midpoint. You have to do it. I don't. Okay, I already did it for you. All right then. Now it also says explain why GH is parallel to DE. Well, since this segment is connecting the midpoints of the sides of the triangle, then it's parallel to this other side. Therefore, you could say that, let us write it over here. You could say that GH is parallel to DE because of the mid segment theorem. As simple as that. Mid segment theorem. Alright? Gucci then. Let's see now. Is there anything in the, oh no! We're gonna die here. Alright, so I'll see you on the next lesson. It's gonna be fun. Alright. Bye bye.